Hello everyone, welcome to my channel Cloud and Data with Kaushik. So today we are going to discuss one problem statement on machine learning projects. Okay. So what we have to do in this project, we have to reduce the time that cars spent on the test bench. So this is automotive company's one problem statement, and this problem statement is on Mercedes-Benz grrener. Okay. So I hope I am audible to all of you, right? Now we are going to discuss the problem statement, and the main focus is that we have to reduce. This is the main problem statement approach. So we have to reduce the time that cars spent on the test bench. Okay, but we have to explore more on the problem statement so we can understand actually what we are going to do. So first we have to understand. So you can see that is the problem statement. So we have to understand the problem statement first. Okay. So this is my Github repository. And here I have added the problem statement. The problem statement scenario, what they have told. So this is the description they have been given. So since the first automobile, the Benz Patent Motor Car 1886, the Mercedes-Benz has stood for important automotive innovations, right? So this includes the passenger safety seal on a crumple zone, the airbag and intelligent assistance system. And Mercedes-Benz applies for nearly 2,000 patents per year, making the brand the European leader among premium car makers. And Mercedes-Benz is the leader in the premium car industry. So this is our main description. So we understood that the problem statement on basically on bench Mercedes-Benz, the automotive company, right? So it's a premium car industry is the leader. Mercedes-Benz is the leader, and to ensure the safety and reliability on every unique car configurations before they hit the road, the company's engineer have developed a robust testing system. So they have before going to configuration they hit the road, the company's engineer have developed a robust testing system. So they have created one robust testing system. As one of the world's biggest manufacturer of premium cars, safety and efficiency are paramount of Mercedes-Benz. So they have focused on the safety and the efficiency, which is it's their unique features. Okay, so they have to maintain this safety and efficiency. So what we have to do, you are required to reduce the time that cars spend on the test bench, right? I already told we have to reduce the time that cars spent on the test bench. Others we work with a data set representing different permutation of features in a Mercedes-Benz car to predict the time. So we have to predict the time it takes to pass testing. How much optimized time or reduced time they have to take it on the test bench. Okay. So optimal algorithms will contribute to faster testing and thus resulting in lower carbon dioxide emissions without reducing Mercedes-Benz standard. Okay. So this is my problem statement, and following actions should be performed that if for any columns the variance is equal to 0, then you need to remove those variables. So first we have to go and see what is the data. So data, you can see we have test and train data set, right? So this is the train and test data set. We have to explore this data set first, and we have to create some optimized algorithm, and we have to choose that algorithm that can reduce the test bench, that optimal speed, right? The reduce the time and that car spent on the test bench. We have to reduce the time. Okay. So they have given some different scenarios like check for null and unique values for test and train set, apply label encoder. We have to perform the dimensionality reduction, predict the test using XGBOOST. They have also told that predict the test values using XGBOOST one machine learning algorithm, right? So we all have understood that what we have to do from the problem statement. Okay, let's go to create that hands-on part, how we can do these things, okay, in the Python. And in this demo, I used that Google Colab. Okay, so you already seen that Google Colab. I This demo we are doing in the Google Colab. Okay, so let's go and start the exploration part of that machine learning part on the project. So this is my Google Drive, and I have the test and train data set in a zip format. So first I have to create one Google Colab file, right? So just right click over here and you can see you have Google Collaborative. Just click this icon, okay? Google Colab. If it is not installed, then you have to install from the connect more apps and then you have to install. Like you have to connect more apps and then you have to install. So I have used the Google Colab. So you can see it's loading. So it will execute, right? Now my Google Colab laboratory is up and running. And you can see once the Jupyter notebook is available, na, also it is already be there. Now first we have to change the name. You can write so the file name is changed, okay? And if you go and just refresh, so you can see that Jupyter notebook, this file is available over here, okay? So this is the file. It takes some time to load the entire file. So you can see the Google Colab file is there. So now what I have to do? First, we have to import the libraries that we all know. But I have the data set and main challenge is that I have to add the data set here. Okay. So it's a runtime environment, or you can see there are different files are there, right? So it's a you can upload the files directly from here. You can also refresh that file, right? Means that folder structure, and you have to mount also, right? So Google Drive, one feature is mount. You have to mount your drive. So we have to see how we can do that. First, we take some uh, It is a refresh button and you can mount your drive. And this is the show hidden files. If you click, so you can see .config on hidden files is there, right? So this is 4 icons that I have explored that upload your files. So you can upload directly here. Otherwise, one main thing that you have to mount. So mount your Google Colab folders and files. So I'm not going to upload the test and train dataset, right? They have given to me train and test dataset, but I'm not going to upload here. Instead uploading, I can mount the drive and then from that drive, entire file system is accessed. We can access from there, right? So what I'm going to do, I'm write from google.colab. You can see google.colab and import your drive, right? Import drive. Okay. And then this is first line you have to add. So we have to import drive from where? From google.colab. And now next line that we have to drive.mount. Okay, we have to drive.mount our drive, right? So you can write content /drive. Okay, this line you have to add and just run the cell. So you can see the cell is running and it connects to the Google Drive. So permits this notebook to access your Google Drive files. Okay, this notebook is requesting access to your Google Drive files, and for that you have to click on connect to Google Drives. Just click. And your authentication part is there. So you have to just click over there. It is your account, right? It is your account. You have to click this account and you can see there are a couple of options, right? This will allow Google Drive for desktop, see, edit, create, delete, all of the features that can be accessible from this Jupyter, this Google Colab notebook. Okay. So if I allow, then only it will be accessing all the things. Okay. Now you can click on allow. Now you can see my drive will be mounted. You can see the message is coming, mounted at content/drive. That means that drive is mounted. Okay. Just go over here and just refresh. Refresh this button and you can see drive is available over here. Okay. So content and drive, and inside the drive you can see entire folder in my drive that can be accessible over here. Okay. Just explore this button. A minute. I think some problems in my laptop. That is the reason it's not showing. But if you explore now, the entire file you can see. So why it is not coming? Just a minute, I have to explore this thing. Just a minute, guys. Now my drive is mounted. This feature means this is not exploding currently, but it will be in your system. Some problem is there, so that's why it not working. But anyhow, we can see that. So you can see there is no such file because CSV file is not there. You cannot access because this file is not content, is not access, right? Because we have the zip file, not CSV file. Okay. Next, what we have to do? We have to unzip that zip file, right? So email project content my drive slash email underscore project slash send dot zip. We can see that folder is there inside the my drive, and just you can see my drive is here, right? So there are a couple of folders inside the drive and inside the my drive section, right? So content and coming, why it is not there? So content, you have to see the my drive, and inside the ML projects, so you can see train.zip file is there. We have to explore something and it will be connect. We have to extract this train.zip and it will be in the train.csv file, right? Let's do what we have to do for that. So you can see content my drive. So it's if I run the shell, so it will not work because inside the content I have the drive folder that I have to mention. Okay, and then my drive email projects and train.zip, right? And press Ctrl Enter. So you can see archiving from this location and inflating train.csv file. Okay, so just refresh. You can see train.csv file is coming after unzipping that. Okay, so we have to unzip the train.csv. Now in the same way, we have to unzip the test. We have to unzip the test.csv. Just copy this line and just paste over here. Instead of train, you just write test and press Ctrl Enter. And you can see test.csv also present. Just refresh and your train and test CSV file is present. What I'm doing, instead of uploading from here, right? I'm not going to upload from the session. So instead of uploading, you have to mount your drive, and once your drive is mounted, then you have to unzip the folder, unzip your data, right? From 10.zip and test.zip. Okay. Next, this is the one part where our data is available in this location, right? Now we have to import. So just write one thing over here, and the text you can write reading the data sheet. So I can prefer that you have to make one heading so anybody can understand, right? So reading the data sets. Okay. Reading the data set. Now, next one we have to do, we have to import the necessary libraries. Just write, and here you can take the text cell, okay, instead of code. So just take text cell and write import the necessary library. Okay, and this is the output. Just make it bold, and then you can import your libraries. So what library that I'm going to add? First, import your pandas. That is all famous. Without pandas, we cannot do anything in that data analytics part. Data science, data analytics, right? This is a very important library. And then pandas is used for reading the data. Okay, like there are various data formats: CSV, HTML, text, JSON. So we have to use the pandas library. Okay, numpy is used for numerical one, right? So pandas, I'm just right, used to read various data format. NP, I can write used to calculate numerical data, calculate with numerical data. Okay. Now we have to import the matplotlib for data visualization, right? Some data visualization part also be there in this project. So we have to import the matplotlib and then dot, you can say it's coming automatically, right? So pyplot and plt, as means allies. Okay, for data visualization, okay. Next we have to import seaborn. On seaborn, this is also data visualization on top of the matplotlib, okay, as SNS. And import warnings. So some warnings may come. So that is the reason we have to ignore these warnings. Okay, so that is the reason warnings you have to import, and then you have to write warnings dot filter warnings. You have to filter this warning. Filter warning, and you have to pass the ignore. So it will ignore the warnings part. That is the reason this warning part is there, right? So this is the libraries that we have to use. Also data visualization on top of matplotlib. Okay, warnings may come. That is the reason we have to import, and we can ignore these warnings. As of now, we don't require these things. Okay. Now we have to run the cell. You can see run cell, control plus enter. So your cell is working there, and there is no errors, right? And one thing I'm not discussing, that is your runtime. Okay. So you can see that there are various options: run, all, run before. You can run entire cell at a time. So you will execute one by one. Okay. You have to run before. All the comments are there, and you have to change your runtime type. Okay, just click over there, and by default runtime is Python 3 or R. So we are working in Python project, so Python 3. Okay, and hardware accelerator is CPU. So I'm not going to use other TPU and T4 GPU. That is mostly working in the deep learning kind of project. Their data set are massive, and by default it's okay for the CPU. So you have to add the CPU, okay, and it will save. So your kernel, or you can see the runtime environment is ready, and you can also explore this thing, additional connection of option. So you can also view your resource, you can manage your session, you can view your resource. You can see this is the resource that we are going to use, Python 3 Google Compute Engine backend. So it's a managed service. We are not going to manage all the hardware part, okay? All the accelerated hardware part, we are not going to manage. This is Google can manage all the things on behind that. You just write and control enter, but you have to understand from where the code has been executed. Some backend is there, right? This backend is your managed resource. This resource you are not managing. This is a managed service, and Google has managed these things. Okay, you can see they're connected to Python 3 Google Compute Engine backend. So GCP backend we are using. Okay, and RAM, you can see RAM 1.15 GB. Disk is available 26.90 utilized out of 107.72. Okay, these all are predefined. These resources you are not adding. Okay, you just click and create your IPYNB file or Google Colab environment. Rest of the things are taken care by the GCP or Google. Okay, from the Colab lab. Okay, and you can also share. You can see these two things are there. You can also share your notebook. Suppose you are doing this project collaboratively or your organization, so you can also share this file. Okay, so you are just write your to whom you are going to add, so and you can done, and then this file will be available to this person. Okay, you also restricted, you can also anyone with the link, so you can restrict as per the organization, so only your organization can view this file if you have restriction is there. Otherwise, if you do publicly, so you can do anyone with the link, so anyone can explore this data, this IPYNB file, Google Colab. Okay, and you can also comment this section. Okay, so that is some bare minimal necessary important thing that we have to know when we are exploring the Google Colab. Okay, so as of now we are okay, right? We have import two tasks we have done. We have reading the data set from the with the help of Google Colab mount drive.mount, and we have also unzipped the file test and train dataset. We have train and test dataset both. Okay, and import the necessary lines. As of now, we have done. Is there any questions as of now? Okay, next task is that we have to read the dataset, right? So just take one text step and we just write read the train data. Okay, we have read the train data. What is the command? It is very simple, that pd dot read csv. So this is my train underscore data is equal to pd dot read underscore csv. Okay, and you have to take the path. Okay, read csv. You can see the definition of means it's just a method, and you have to call this method from that pd. Means you have to import this pandas library, and you no need to create this definition. Definition is already created in this class. Okay, you just call the function. Okay, you no need to create the definition. You can see this is the dev read underscore csv. You have to file path, or you have to that file path can be string. Everything is given here. You can just explore these things, and you can see as a tooltip format the entire information are coming. Right? So you have to provide that CSV. So CSV file path you have to add. So this is my file. We have to read the train data, right? Just click the three dots and copy the path. You no need to understand where it means. You no need to read about the path. You just copy your path, okay? And then you have to paste content train.csv. Automatically the path will be right accordingly. Your path will be created, okay? Right? You have to take the same. You have the folder, new folder, and I just create data. Okay, inside the data, if I will create one file, right? New file, and the file name is abc.txt. Suppose it's an example, okay? Just inside the data, you just add this path, okay? And now you can see every top and every hierarchy, the three dots are coming. Data also three dots coming. ABC also three dots are coming, right? Just go and copy path, and you can see your path is automatically changed. Content data abc.txt. Okay. So you no need to worry about the path. Just copy the path from, just click the three dots and you have to copy the path. Okay. And content underscore train.csv. Then you have to just click the cell and you can see run cell, control plus enter. Okay. Just control plus enter. So the data, everything, whatever they have executed, that is stored in the train.data. Okay. Now same way we have to read our test data. So just write over here train and test data. We have to read. Okay. So write train and test. So train is there, write test data. Okay. And then write ed.read underscore csv. And same way you have to mention the path. Just go and copy the path and just paste over here. And this path should be string. If I will write in this way, I forget to add the string, right? What it will show? Just take a look on it so you can understand. So in the next time you can add the string format. So invalid syntax, it is treated as a variable and it's a long path. Okay, it cannot understood. What is that? Content, test, CSV, you cannot understand this. Okay. So instead of that, we just write this one. Okay, each and every line I'm going to explore so you can understood. Okay, and test and train data set is reading, but I am not displaying this. Everything is there inside the train and test data, right? Now take another code, or you can take another cell with the text cell, and what I'm going to write, read, just write read first 5 rows from the data set, train and test. Okay. So what I'm going to write, train underscore data dot head. So if you write dot head method, this is also coming from this definition head. You can see this is the return the first n rows, and you can also parameterize. You can also add the parameters over here. Okay. By default, you can see 5. So it may ask anyone that how many rows by default is coming. By default, 5 rows, number of rows to select by default. And you can also select any number of rows by mentioning that number. Okay. So you have to read the first 5 rows, train underscore data dot head, and you can just explore control plus enter, and you can see first 5 rows are coming, and you can see 0 to 4. 0 index it will be starting. So 0, 1, 2, 3, 4. First 5 rows it will be showing, right? And also you can, they have suggested some chart. Just click. Very nice, right? They have suggested some chart over there, the distribution charts. Okay. So as per the data set that they have suggested, this kind of chart you can add over here. Okay. I'm not going to add anything. Just write, and then I just write. Just click on this cell. Okay. So this very awesome thing, right? You can see all the charts are coming, the available charts, right? As per the data they have assumed, they have inferred this kind of chart may come, that kind of distribution may come, this kind of categorical distribution, numerical distribution, and 2D distribution, time series, values, everything they have mentioned. Means the chart is coming automatically. Okay. Very nice features, these things. Okay. And anyway, so train data we have read. Next, we have to take the cell over here. Just a minute. Now we have to run, we have to see the test data dot head. Okay. Train data dot head we have to see, and then test data dot head we have to see. So we already seen that 10 data set and now test data set. So 10 and test data set by default they are given in the problem statement. Okay. And you can see test data set. Okay, same thing you can click on there. They are providing the suggested set. And now next question is that if I want to show how many rows and columns are present in the data set. So I will write over here how many rows and columns are present in this train and test data. Okay. What we are going to write train underscore data dot set. Okay. This is rows and this is the columns. Okay. Rows 4209 and 378 is the column. Same thing in the test underscore data dot set. How many rows and columns? Obviously it will be 4029377. Okay. This data. And one more thing, that the data, whatever the train and test data we have, right? What type this is? We have to understand the type of data set, right? Train and test. Train underscore data, and you can write the type. Okay, just write print data type of train data set. Data type of training data set. Just copy this line and print. But I have one doubt in the test data. Also, the same rows 40209, 4209. Just a minute, I have to see. Let's explore this thing first, and then I'm going to. Yes, right? So both are pandas data frame, okay? Pandas.code.frame.data frame. Test and test data set, okay? This is right, test. So data type class is pandas. Core frame.data frame. So no doubt it's a data frame object, okay? So you just write type and add plain underscore data. You just write type and this is your test underscore data. Both are pandas data frame object, okay? Have next we have to see the columns name, but it's a too long. 378 rows are coming. Let's still have a look on that. So print underscore data dot columns. It will. Okay. So this is the columns. So dot means it is there. In between many columns are there. Okay. So check the columns name from training data. Just add print and write. Here I am write if string. Okay. So this is very easy. So check how many rows, how many columns, check columns name or display columns name, not check. So display columns, okay. And for training data, for training set, just copy this line and just paste over there, and that should be testing data set, and you can write test data columns and then it will be printed. Okay. So this is very basic inference, basic information, right? That we have to explore before going to move that machine learning, all kind of stuff. More things we have to check. Okay. So that is the reason I am adding line by line. Okay. Next, you just add, instead of comment, you just add one heading. So it will be more helpful. Training and right. Now next we have to explore that 5-point summary, means how many means, mode, median, 25 percentile is there, right? So just do one thing, print data and then dot describe. So you can see that column wise, that count, mean, mode, median, these values are present. You just write only one command or code, okay, describe, and then you can get all the details. Okay, so just write display 5-point summary of training data set, training Okay. Next, display 5-point summary of test data. It will be explored on a minute. Yes. So test underscore data dot describe. So, yeah. So you can get all the these details, right? So as of now, we are okay. And next, we have to see one. We have to check what is our task from the problem statement that we have to explore. So for any column the variance is equal to 0, then you need to remove those variables. Okay. So we have to removing the variables, those having 0 variance, right? This is the first task. So doing this task, we have to explore one more thing, and that is you have to only take the object, data object, okay, from the training data set, because there are different kind of data is there, right? So we have to explore only the object. So for that, I can write for I in train underscore data. This is my data variable, train data, and dot columns. Okay. And just write data underscore type is equal to train underscore data. Each line one by one, it will be check. Okay. Data dot d type. D type means data type. Okay. D type. If just add on condition, data type, data underscore type is equal to object. We have to see that the object data only. Okay, I just forget to mention the colon, and then we just add. So this x0 to x8, this is only object. Okay. Rest of the things we have different kind of data. So just write, we have to know only the object data. Okay. How can I do that? So this is way you can print and your object data only be showing, right? X0 to X8. And my one question is that, and how we can know the data type of each column, right? So just write over here and just write in the text how to know the data type from training data set. How we can know the data type? Means data type only you have to check the object, but we have to more explore the data type. How many data types are there? Okay. Now we have to know the data type. So write train underscore data dot d types. Okay. And just add, and the d types is a attributes. Okay, you can see d types, and you can see it's a property d types. Okay, and there are 378 columns are there, length and d type. Some kinds of integer, float, object. Only you can see we have to take the object. Okay, this object we have to separate. We have to take. Okay, same in the trace data. Trace underscore data or two types. Then explore any and data. Now the first task is there. We have to remove the variables having zero variance. So, right, removing the variables having zero variance. Let's so write variance is equal to this method POW. Just read equivalent to base into expression with two arguments, and sometimes such as integer are able to use a more efficient algorithm when invoked using three argument form. So I am using this POW. Okay, and just write train underscore data drop. You have to drop the columns ID and Y. I don't require ID and Y variables. Okay, it can disturb. So write columns is equal to ID. So columns name we also shown that is ID on the training, right? From where we are going to remove from the train data, right? So ID and what, comma Y. Y is there. Y, ID and Y. We not require this thing. We have to remove this thing from my data set, right? We not require ID and Y. So drop is a method where you can add and we have to remove those columns. Okay. I'm just write and then I'm going to explore these things. So after dropping the ID and Y, the standard deviation may infer and then convert is the dictionary. So just let to take a look on the variance and how it looks like. Okay, it's a variance part. Okay, and then this data is coming. we have to remove the variables having zero variance. So we have to write more things over there. I just calculate the variance. Null underscore count is equal to 0. And take one for loop key, comma value in variance dot items. Okay, these are all items. So you have to take variance dot item. This object will come. And what's the type? The variance type. You also look these things. Just go and write here type dictionary, right? We have to create the dictionary. You have to convert it as a key value pair. You can see this is a key name and this is a value. Okay. So we have to convert it to a dictionary format. So variance is currently dictionary. And on top of the dictionary, we have to creating the for loop. And we have to take the key and value. Understood? This is the key x385, x384, and this is the key and this is the value. Okay. Now I can write if value is equal to 0, then print the name this is the key, right? We can print it and we have to write null underscore count is equal to null underscore count plus 1. It will increment one by one and then write the print statement. We can write number. We can take F string over here to number of columns each has 0 variance. Okay, and that is your null count. Just press Ctrl plus Enter. Removing the variables having 0 variance. So the output is 12. 12 column that have 0 variance. That we have to calculate. Okay. 0 variables we have to calculate. So first this task is done, right? Removing the variables having 0 variance. Very simple thing I have to do. We have to drop your ID and Y column from your train dataset, and you have to take this standard deviation and then you can see dot std method. Okay, and then to dictionary, you have to convert it to the dictionary, and this is the variable. So dictionary is there means key and value pair is there, right? And also see the type of variance. This is the type of my variance. So it's a dictionary, and then we have to create the for loop, and we have to know that value is 0, and we can print the name and also count. So we have to understand, we have to know that how many number of columns are present, the 0 variance, right? So that is the reason we have to print this name and null count. You have to add this, right? We can understand this. Very simple. Next thing is that some columns are not required. So you have to drop these columns. Okay. So that also see that check for nulls and unique values for train and test data, right? So just take the text and drop some column which is not required. Which is not required. So write train data, train underscore data is equal to train underscore data dot drop, and you have to mention the column's name. Okay, you have to mention the column's name. This column's name, na? So you have to drop it. It is not required because zero variance is there. So x11 comma x23 x235 this has a zero variance, and then not required 89 290 293 x297. Okay, and then these are the column, those have zero variance. You just add these things and x347. Okay, so before dropping and some kind of modification of your main data set, na, I recommend you have to copy this thing. So train underscore data underscore copy, take one variable and write train underscore data dot copy. If anything, any accident is happened, right? If any columns are mismatched or any operation you are doing, if main data set can be disturbed, right? So take, for your safety, take one copy. Okay, and this is copy and dot get. You can see this is from the my main data set. You can copy the data set. So it's best practice that you can copy the data before exploding or before modification. I mean, if anything is happened, you can take the reference from there. So you can take one copy from there. Okay. Now 10 data set, I have to remove those 12 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So these two columns I have to remove. And then we have to take 10 data. First we have to remove, and then we have take the 5 rows. with the head columns. Okay, so just yes, it's done, and just write your train underscore data dot head. Just write 4. So only first 4 rows, only first 4 rows will be available, or will be shown, not available because it's there, will be shown. Only first 4 rows, okay, 0, 1, 2, 3. So these 4 rows will be shown. Now you can see that after removing the columns, right? So 366 columns are there. Before that, 378 columns were there. And now I have to minus 12 columns. So just check 378 minus 366. So 12 columns I have removed. So it's successfully removed. So currently in that, after drop the column, we can take one loop of my data set, and the column's name is 360. That is the reason I have used the head. So you have to check these things. And same way, if you just write tail, now we have to take is it looks right. So 366. Now we can write the train underscore data dot tail, and only first last 4 rows. Okay, just write over here. Sorry, only last 4 rows. So I till, and you can see this is the last 4 rows of your in data set, right? And also you can confirm train underscore data dot shape. It will also tell the same thing. 366 columns. After dropping, how many rows and columns are present in this data set? So that is 366. It is okay. As of now, is there any doubt? No, right? I hope I have mentioned each and every line you have to explore so you can understand. Now check for null and unique values for test and train data. The second task, just you just remove this cell and write what we have to do. We have to do train and test, right? Check for null and this train data set first. Test and train. Just do null and unique values test data set, our test underscore data dot, I already used this thing, is null dot sum dot any to false, and same thing we can write train underscore data dot is null dot sum So there is no train and test data. And if you write dot any method, so it will provide the Boolean value, either true or false. So there is no any such kind of null values are present, right? Next, we have to apply label encoder. Yes, you can see this is that data that we have to print. And we have to know this thing, the unique values that are missing. So just write train data dot. I already created this thing. So that is in unique. Okay. So in unique, if you write, then your test data set value you can print. Okay, in unique. So this is unique. How many unique data set? How many unique values? Unique values are present. Very simple, straightforward comment, right? Train underscore data dot anything. Now we have to apply the label encoder part. Okay, so just go and apply label encoder. Okay. So what is the concept of label encoder? That we have to know. What is label encoder? We can apply, but why I'm going to apply this thing, right? What is the intuition behind that label encoder? That we have to know. Because they have told we have to apply the label encoder. You can see, I already applied, but why I have to apply the label encoder? What is the reason? That we have to know. But before going to that, is there any doubt from your side? So please confirm. So otherwise we can proceed. So label encoding, now I'm going to explore this thing. So label encoding you can use, or it is used in machine learning to convert your categorical data. Okay, because machine can understood the numeric value. Categorical data which represent labels or categories, right? We have some categories, we have some labels. Okay, and then we have to convert it in the numeric forms. Many machine learning algorithms require numeric input and label encoding. So I'm just writing this thing and just create one new file and write the label underscore encoder dot txt. Okay. So write label encoder is used in machine learning to convert categorical data which categorical data into numerical forms or values. Okay. That means which category has which represent, you can write which represent categories or labels. Okay, labels, and that value we have to convert. We have to convert in numerical values because machine can take numerical form. Take numerical form, and those labels also we required. Right? So our in your case, labels is important. You can understand, but machine cannot understand the categorical form. It can convert this form, right? For example, I'm giving one example. If you have categorical features like color, okay? So right, if you have a categorical feature like color, you have the color. This is one category. It is our label or categorical feature. This is my color with some categories. What is the category? That is red. Red is one color. We have green is one color. Okay, and we have blue is one color. Okay, this is my label. These three label. Encoding. This could assign numerical values like red 0, green 1 and 2. So for machine this is 0, 1, 2, but for me it's red, green, blue. So that is the concept of label encoder. Okay, 0, 1, 2. This numeric representation allows machine learning models. So you can write, to me this is red, green and blue, but machine can understood 0, 1, 2. That is the reason we have to convert it. Okay. So label encoding or label encoder applied to only ordinal categories. You have to understood. Label encoder should be applied to ordinal categorical data. Ordinal categorical data, label encoder. Okay, where there is an inherent order. Where there is an inherent order among the categories. Okay. some problem is there among the